Let's start to talk about differential equations. Differential equation is some equation where we have a function and some of its derivatives. Here is one differential equation. We are asking for a function in such a way that the derivative of the function is the same as the function itself. Here is one solution for this equation, and here is the general solution for this equation. There are no more solutions. What would be the solution of this equation? Well, you might guess that this function satisfies the equation. Let's see what is the derivative of this function. It's something like this. So we see that it satisfies the equation. How about this equation? The second derivative of the function is minus the function. So, do you remember any familiar function which has this property? Well, both cosine and sine are such functions that if you differentiate them 2 times, you will get back the same function with the minus sign. So, we can take the linear combination of cosine and sine, and that is the general solution of this equation. How about this equation? This equation is separable. There is some function of x and a function of y, which are multiplied together. Separable means that we can easily arrange the equation in such a way that we can integrate on both sides. We can write the derivative of y in a little bit different way. And we can think that these dy and dx would be some numbers. Then we can do the separation. We have got all the y variables to the left side and all the x variables to the right side. We can think that now we just want to integrate on both sides. Here sometimes people are confused with this natural logarithm of absolute values of y, but the function is quite normal and its derivative is here, this 1 over function, both for the positive values and for the negative values. So everything is okay here. Now let's just take and put both sides to the exponential, and we will get that y of x is e to power sine of x plus some constant. Well, we can use this formula here to write it in a little bit different way. Like this. And now this constant here we can write in a little bit different way. Maybe we just call this a. So there we have our solution. Well, now if we look at the original equation and we think that our function would be some constant times. Oops, there's a mistake. Not like this, but e to power sine of x. E to power sine of x, and we would differentiate this function. What would happen? We would just get the same function as before, but multiplied with this cosine of x. So, yeah, this function clearly satisfies this equation. So we found one class of equations what we can solve. These kind of separable equations we know how to solve. It will be so that we can also solve these kind of equations. There is even a solution formula for these. let's calculate the derivative of y. So we need to differentiate the first function. It will be just staying the same, except we'll get the derivative of the inner function. That will be times minus b of x. Then we need to differentiate the second term from here. And how would that be? We would get just the same thing what is there. Okay, here is the derivative. If we differentiate this one here, we will get this term. And if we differentiate this function here, we will get this other term. Let's see how to write it. This one will become this one. Well, let's see then how is this y prime now. This term and this term will cancel out and we just get q. And then when we look at these first two things here, it seems to be like that these are just minus b of x times y. So if y prime in the equation is equal to minus bxy, we would get that these things cancel out from here. So it seems that this is the correct solution. The formula is looking very terrible, but don't be scared. We will practice this next week. So now we know two equations what we can solve. Two differential equations. Well, what's the meaning of this word linear and what is the meaning of this word first order? This first order just means that when you look at here is the first derivative and there are no higher order derivatives. Well, let's look at this differential equation. What is the order of this equation? We need to check that what is the highest order of the derivatives. We can see that here is the third derivative and here is the zeroth derivative. So the highest order seems to be 3. This equation is of order 3. Well, what's the meaning of this word linear? We can study the linearity of this equation by writing the equation in this form. Let's have this differential operator of y. We will put there everything what is in the left side and then put minus everything what is in the right side. Like this. So how is our operator L? Let's study a linear combination of two solutions or two functions. I see that there is a mistake. We should not have any terms which depend only on x. Now the differentiation is a linear operation, so it means that we can take the derivative separately. So it seems that we can now do this thing. We can gather the terms like this and take C1 and C2 as common factors. And this is what we got. L from this linear combination is the linear combination of these L's. So this shows that L is linear. So how about now? we know how to solve this first order linear equation. Can we solve this second order linear equation? Even for this equation, there is no general solution method. But if these functions here are constants, then we can do something. Let's at this point forget this function. We can study this equation where the coefficients are constants. Very easily in differential equations, the solutions are given by some exponential functions. Even in this case. So let's guess that y is some exponential function. Here we have some parameter lambda. It's a Greek letter. Because of this guess, we can calculate what is the derivative of y and the second derivative of y. By substituting these to the equation, we obtain this. Now we can take this exponential as a common factor. We see that this exponential is always non-zero. So if we want our equation to be true, and we mark this new equation to be 0, we must have that this polynomial is 0. Well, we see that we just need to solve this kind of equation, and after that everything will be okay. Then we can write our solution. Next week we will see the details how we can get the solution in this case. Next week we will also find some more equations what we can solve. Next week we will talk more about these equations. Already we saw that it is important to notice when an equation is separable or linear. So there are a couple of quizzes about this.